Hello and welcome in this new video. In this video, we're going to solve the question number 4 of assignment 3rd in data science. Question number 4 says, given the confusion matrix, find classification and accuracy, precision and recall type 1 error and type 2 error and F1 score. Sensitivity, specificity, explain the important topics of precision and recall as a compared to accuracy with the one example. In the given chart, confusion matrix in machine learning. Confusion matrix is simple table used to measure how well classification model is performing. It compares the prediction made by the model with the actual result and show where the model was right or wrong. This helps you to understand where the model is making mistakes so you can improve it. It breaks down the prediction into the four categories. True positive is TP. The model correction predicted a positive outcome, e.g., the actual outcome was positive. And true negative. Then the model correctly predict a negative outcome. The actual outcome was negative. The third one is false positive. The model incorrectly predict a positive outcome. The actual outcome was negative. It is also known as type 1 error. Fo- Fourth one is false negative. False negative. The model incorrectly predict a negative outcome, i.e. the actual outcome was positive. It is known as a type 2 error. In this given table, it also help calculate the key measure like accuracy, precision and recall, which give a better idea of performance and especially when the data is imbalanced. Metrics based on the confusion matrix data. Accuracy. Accuracy show how many prediction the model got right out of the all predictions. It gives the idea of overall performance, but it can be misleading when one class is more dominant over the other. For example, a model that predicts a majority class correctly most of the time might be have a high accuracy but still fail to capture the important details about other classes. It can be calculated using the below formula. Accuracy equals to TP plus Tn upon TP plus Tn plus TFP plus Fn. Precision. Precision focus on the quality of the model. Positive prediction. It tells how many of the positive prediction were actually correct. It is important in the situation where false positive need to be minimized, such as detecting spam emails or fraud. The formula of precision is equals to TP upon TP plus FP. Recall measures how good the model is at the predictive positive. It shows the proportion of true positive detection out of the all actual positive instance. High recall is essential when missing positive cases are significantly consequences like in the medical test. Recall formula is PP upon PP plus FN. F1 score. F1 score combines precision and recall into a single metric to balance their trade-off. It provides a better sense of a model's overall performance, particular of imbalanced data sets. It is helpful when both false positive and false negative are important through it assumes preci- precision and recall are equally important. In some situation, one might matter more than the other with the given formula. Fifth one is specificity. Specificity is another important metric in the evolution of classification model, particularly in binary classification. It measures the ability of a model to correct identify negative instance and significity is also known as the true negative rate. Formula is given by. Let's move on to the type 1 and type 2 error. Type 1 error, it occurs when the model incorrectly predict a positive instance but the actual instance is negative. This is also known as the false positive. Type 1 errors affect the precision of model which measures the accuracy of positive prediction. Let's move on to the type 2 error. This occurs when the model fails to predict a positive instance even though it is actually positive. This is known as a false negative. Type 2 error impact the recall of model which measure how well the model identifies all actual positive value by the given formula. Example, a diagnostic test is used to detect a particular disease in the patients. Type 1 error is false positive. This occurs when the test predicts a patient has a disease positive result, but the patient is actually healthy and there is a negative case. In type 2 error, false negative. This occurs when the test predict the patient is healthy negative result, but the patient is actually has a disease. It is a positive case. Fourth question, have a table in assignment. The accuracy. Accuracy means the overall consequence of the model, e.g. propagation of all prediction that are conceptually 70% of functional are concerned. This is some example to show importance. Suppose we build a cancer detection machine learning model for 100 patients. 10 have cancer positive cases and 90 don't have cancer. It is a negative cases. Model prediction, the outcome column and the count of patient. True negative equals to the 70 and accuracy the model looks good 77% accurate. But the model missed 3 cancer patient FN, very risky in medical diagnosis. Precision. Precision is equals to the 25% of the people are predicted as a cancer positive actually have a cancer, lots of false alarms. In the recall model have a 70% of actual cancer cases, but miss the 30% patient, which is dangerous. Summary in the simple line, matrix problem if it is low and accuracy model fails overall. Precision, how false alarm FT waste time and source. And recall miss real positive cases FN and critical in high risk tasks. Final take away accuracy alone may hide real performance and precision and recall together give a deeper insights and especially for the imbalanced datasets and critical applications like fraud detection, cancer diagnosis and spam detection. And other one is instruction detection. Thank you for watching this video.